Okay, hello class. I'm going to start the session and I've started recording. So the idea was to maybe address any questions that students had, the previous learning units that they've covered. Um, but instead, if there are no questions, I am actually going to talk about probability. So that will be learning unit 5. Okay, so I'm going to illustrate this section with an example. So I'm going to share my screen. Okay, so here's the whiteboard. So in this example, I'm going to basically talk about two variables, and which are illustrated by a cross-tabulation table. Okay, cross-tabulation table, this basically means showing the interaction between two variables. The one variable which runs across the rows is positions in a company. So you can be either a director, a manager, or a junior position in the company. So that's positions in a company, which is one variable. The other variable is the industry sector. And in this example, we're only considering the mining and the finance sector. All right. So what this table tells you basically, if you just look at the number 21, that tells you that there are 21 directors in the mining industry. If you look at the 160, what that's telling you is that there are 160 managers in the finance sector. And then we have the totals in the last column in the bottom row. So basically, if you look at the 61 total, it's adding up all the directors. Whether you're in mining or finance, we've added it up and we've got 61. And similarly for 240, that means we have 240 managers in total, irrespective of their uh, industry sector. And in total, that is adding up all observations, we have 751. So if you add up all the directors, all the managers, all the juniors, you'll get 751. All right. The same goes if you add up all staff in the mining and the finance sector, you get the same 751. Now the 311, that's how many staff you have in the mining sector. So we're adding up all the directors, managers, and juniors. All right, so this is the information that will be given to you. You'd often be left with calculating the totals yourself, but I hope you understand that basically how you do it. It's pretty simple. You'll need the column totals, you need the row totals, and then the grand total. The 751 is the grand total. Now for probability, basically a probability is, okay, if you give me a second, I'm gonna use the whiteboard and do some writing. So probability is basically looking at the number of occurrences of a certain event divided by the total number of occurrences. So think about it this way, right? If you have in a hat, right, you have 2 red marbles, right, amongst 10 marbles. So the rest of them have different colors, but there's only 2 red marbles. And if I asked you, okay, what's the chance of getting 2 red marbles out of those 10? So then the probability of getting 2 red marbles would be 2 out of 10. How you got that is basically you're taking the number of occurrences of red marbles, which is 2, and the total number of occurrences means how many in total do we have, and that's 10. So it's 2 out of 10, which is like 20%. All right. So that's basically how probability works. It's determining the number of events of interest divided by the total number of events. All right. Let me change this to, and all right. So let's say you're asked to work out the probability of being in the mining sector. Okay, so you're told probability of working out of being in the mining sector. I'm just going to write MIN as a short form, right? But know that it means mining, okay? So the probability of being in the mining sector. Well, like I said, it's a number of occurrences of interest. In our case, the events of interest is being in the mining sector. So we have 311 occurrences of being in the mining sector. Okay, if you look at the total for the mining column, and the total number of occurrences is basically the grand total. It's how many observations you have in total, so that's 751. All right, if you work that out, highly encourage you to express this answer as a percent when you're doing this in your exam and your tests and your assignments. So it's 41, and get into the habit of rounding to 2 decimal places, 41.41%. Right. Similarly, if you're told, what is the probability of being a director? Okay, so DIR for director, you look at how many directors there are in total. Well, that's given by the total here, 61. That's how many directors you have. So you have 61 directors divided by the grand total once again, which is 751, and that'll give you a percent of 8.12%. 12%. All right. So pretty simple how to work out probabilities. What you can get asked is to work out the joint probability. A joint probability is just simply the occurrences of two events happening together, so jointly, occurring jointly. So say you were told, what is the probability, or you were asked, should I say, of being in the mining sector, so MIN, and on the right, instead of writing N, I'm going to write the math symbol for it. Okay, it's intersection. Okay, it's like an upside down U. Probability of being in the mining sector and being a junior. All right, you asked this. So now you would look at how many occurrences where do we have of juniors and in the mining sector, or in other words, how many juniors do we have in the mining sector? And that's where they intersect. If you look at where mining is, if you run your pen down here, and where it intersects junior, that's 210. So that's 210. That's the number of occurrences. And once again, you divide by the grand total, 751. And that'll give you a percent of 27.96%. We'll check the chat now. I think I got a message. That's joint probability. Okay, let's see where we are. Oh, no messages. Okay, let's go back. All right, so that's working out the joint probability. All right, the other thing you need to know how to work out is actually using the addition rule, and that comes into effect when you're asked to work out one event or another event happening. Okay, so think of the word or as a key indicator to use the addition rule. Now the addition rule is this formula here. I think it's given to you in your formula sheet, so you don't need to memorize it. Probability of A or B. I can write the word or I can use the math symbol union, right? It's the same thing. That is given by probability of A plus probability of B minus probability of A and B, or I'll use the word intersection. Sorry, I'll use a symbol intersection. Know that this is the same thing as and. That's the formula for the addition rule. So now we're going to use it in this problem here. Let's say you asked to work with the probability of being a director or being in the finance sector. So probability of being a director or being in the finance sector. I use the symbol for or, and I'm write FIN for finance. So now we're going to use the formula that I'm kind of putting in this block. Instead of A and B, we have director and finance. So all you have to do is substitute director for A and substitute finance for B. Okay, that becomes, now if I'm using the formula on the top, it becomes probability of director plus probability of finance minus probability of director and finance intersection. Right, so We'll work that out. So the probability of being a director, we actually worked it out already. It's this here. Okay, it's 8.1. I'm just going to write the fraction though instead. I'm going to write it here. I'm going to write this part here because in the end I'm going to put everything in the percent. So it's 61 over 751, right? Plus probability of being in the finance sector. That is, well, how many people do we have in the finance sector? 440. So it's 440 divided by the grand total minus this joint probability here. Probability of being a director and being in the finance sector. Well, how many directors do we have in the finance sector? The intersection, it's 40. That's 40 over 751. And that gives you an answer of, I believe, 61.38%. All right, that's how you use the addition rule. Okay, the other probability I'm going to show you how to work out is the conditional probability. All right, so if you give me a second, I'm just going to clear this out so I can write on this part of the board. Okay, conditional probability involves using this formula here. Probability of A given, or vertical line to represent given that B has occurred. Right? You don't have to memorize this formula. It is given to you in your formula sheet. You just need to know how to apply it. So it's probability of A given B is equal to the probability of A and B. Okay, remember this is the symbol for and, divided by probability of B. So whatever is on the right of this formula or this vertical sign, it will be in the denominator. But like I said, you don't need to memorize this formula. It's given to you. We're just going to apply it. So now instead of A and B, let's say you asked in the text, what is the probability of being a manager, MAN for manager, given that you are in the finance sector? So now instead of manager, this will be A, and finance, this will be B. So that is, now we're going to use the formula in the block. That is, instead of A, we're going to write probability of manager and finance. So that's your B. I'm going to write FIN here, all divided by probability of finance. Okay, because your finance is your B. So now the numerator, as we've done earlier, this is working out the joint probability. The numerator is the joint probability. So how many managers do you have in finance? Where do they intersect? Well, if we look here, manage and finance, it's 160 of them. So it's 160. So the numerator is that divided by 751, the grand total, divided by the grand total. The denominator, this part, right? So I'm going to write divided by because that's the denominator now. The probability of being in the finance sector is, well, how many people do you have in the finance sector? There's 440 of them. And that's divided by the grand total, 751. Okay. And if you work this out, you'll get an answer of 36.4%. Right, that is basically conditional probability. All right. Okay, class, I hope that makes sense. I'm going to erase this. And that's what I want to cover for probability. I will take you through counting techniques next. Okay. And that's using combinations and permutations. Right, it's gonna almost there. No, I'm actually just gonna take it easy and put a new one. All right, for counting techniques, it's basically determining how many possible ways you can arrange something or draw something or select something. All right, so for instance, let's look at a simple example. Let's say you have three letters. We have the letters, oops, we have the letters A, B, and C. We only have these three letters to work with. And I ask you, how many ways can we draw two letters? Okay, or can we arrange just two letters out of those three? Well, let's look at one possibility, right? One possibility we have A and B, right? The next possibility is B and A, all right? Okay, the third possibility is A and C. Fourth possibility is C and A. Fifth possibility is B and C. And the sixth possibility is C and B. So you can see here, the order does matter. Even though they're the same letters, but whether we have B first or C first, it does matter. So we count them separately. Okay, when the order matters, all right, you can see here we can have six possible arrangements. If I make this make it four letters, A, B, C, D, it's not going to be so easy to determine how many arrangements there are. Okay, so that's why there's a unique, should I say, a neat trick or math formula to work that out, to work out how many arrangements there are. So instead of writing it out explicitly and trying to think of all the arrangements, if I know I have to select two from three possible outcomes, right, where the order does matter, then I would use something called permutations. Right? In your calculator, you'll see something with the N, P, R on your calculator, right? And that's for permutations. So the N is how many are you selecting from? So in our case, the N is 3. There are 3 possible letters, so 3 permutation. And the R is, well, how many from that 3 are we selecting? Well, we're selecting two letters from those 3 letters. So that R is 2. Now, if you work this out in your calculator, you will get 6. And that's how many arrangements we have here. So that's the way to determine how many arrangements there are. Let's say now, however, we got the same 3 letters, but I still want to draw 2, but the order doesn't matter. That means I don't care whether it's A, B, or B and A. They're the same thing. I must treat them as being the same thing. So now the order does matter. So now the possible arrangements are A and B. Okay, that's one option. The second option is A and C. And the third option is B and C. So remember, the order doesn't matter, all right? So that's why we only have 3 now. Okay, so these are counted as the same. That's why we only list them once, right? So now there's only 3 possible arrangements. So when the order matters, so we're still selecting 2 from 3, right? We're still selecting 2 letters from 3 letters. It's going to be 3, but instead of P, it's going to be C. It's combinations. And we're selecting 2 letters from them. And your calculator has this function here. And if you work that out in your calculator, you'll get the answer 3, which is exactly what we got here. We got 3 possible arrangements, all right? So that's how you use permutations and combinations. It's to determine in how many ways can you arrange things. Now, if we have to use this in, say, determining a probability, right? So let's say the question now is, let me just take this out. All right. Let's say we had 5 marbles. Okay, so I'm gonna draw them like in very terrible sketches. So we have 3 red marbles. 1, 2, 3. So there's 3 red marbles, and then the other 2 of the color blue. So we have 5 red marbles in total. 3 are red and 2 are blue. All right. And let's say I asked you to determine. Let's say I told you you can draw 2 marbles without replacements. So say these marbles were in a hat, so you can't see which marbles are in there. But you must draw 2 marbles. You must reach in with your hand and pick out 2 marbles. And the question is, what is the probability of drawing 2 red marbles? Right? What's the probability of drawing 2 red marbles? All right. So the first part, just like how we worked out earlier, to work out probability, you need to know the number of occurrences of the event of interest divided by the total number of occurrences. All right. So the numerator is basically how many ways can we draw 2 red marbles, right? So that's exactly what we just did earlier, right? It's working with combinations. That means I don't care whether I draw, I'm going to put a 1 here, and I'm going to put 2 here. I don't care whether I drew marble 1 and 2 versus marble 2 and 1. They're the same thing because I stuck my hand into that hat, and I'm just going to pull out 2 marbles. It doesn't matter what the order is in my hand. Those 2 marbles are the same 2 marbles. All right, so I can draw marble 1 or 2. Remember, I can also draw, let's say this is marble 3. That's the third red one. I could also draw marble 1 and 3, right? So remember, I want to know how many ways can I draw 2 red marbles. And that's basically selecting 2 from 3 of them. There's only 3 red marbles, all right? So the numerator is 3C2. It's drawing 2 red marbles from 3 of them. And the denominator for the probability is basically, remember, I'm drawing 2 red marbles. I'm drawing 2 marbles from the hat. So I could happen to draw a blue one and a red one. I can draw any 2 marbles out of these 5, right? So the possibilities in total is drawing 2 from 5. So it's 5C2. And if you work this out, that's your answer. That's the probability of drawing 2 red marbles out of 5 marbles. And if you work this out, it'll give you an answer of 30%. Okay, so that's how you use counting techniques to work out probabilities if you ask that. Okay, I hope that helps. Okay, and that's what I wanted to cover today. And I'm going to call it. I hope you enjoy this and it's informative when you watch it and it helps you in your revision. All the best.